Hey there, my name is Larissa Thelen, and I'd like to start by saying that I hope everybody is doing well and staying safe and healthy at home. So to get started, my presentation is called Song of Sea. You'll later find out why. So here's a little background about me. We can read all about that. Let's just get started. So I chose a USB digital microscope because first off, I hadn't had the opportunity to work with it before in our class and the associated software. So I thought it'd be great to use for my masterpiece. It gave me a chance to explore a new microscope. So there's also other reasons why I use this. It provides a great contrast, a color image. The software is accessible from home, and it can also be used to examine many sized items. So ranging from small microns, so like hair sized pieces, to millimeters or centimeters sized samples. So some features and details, just summing up what digital microscopy is, because we didn't go over this. It's just very basic. Images are in color. They're displayed on a monitor as there's no ocular lens in the microscope. The associated software is called Capture 2.0, where you can view your image, you can save it there. The USB microscope incorporates pixels as it's connected to a laptop. So it's great flexibility. You can use it in many different places. It's lightweight, it's portable. There's a large depth of field and with that comes a smaller numerical aperture. There's a long working distance as well. So this microscope provides also 2D and 3D images and stacking abilities, depending on the modes that you choose. It has a great contrast and detail. I think I might have said that. But the magnification, depending on the quality of the microscope. But typically the microscopes will range from about 5 times to 140 to 200-ish. But the microscope I used was 5 times to 140. So the quality of the image is greater as it limits the limitations that our eyes provide. So essentially, when we're viewing it through a little ocular lens, depending on how we're viewing it, that's how our image is going to come out. So this way, we kind of erase any sort of limitations that our own eyes provide for our image. Another plus for using this microscope. So you can use this in the field, the lab, anywhere pretty much. So it's been implemented in many fields ranging from research to development, innovation, manufacturing, biology, forensics, and like leisurely too. A lot of people will buy this specific one. So many different uses there. So let's get to the bulk of like what it does, how it works. So the main features. So there's an integrated camera within the microscope. There's an objective lens. There is also an LED light that is beside the lens. There is something called a CCD, which is a charge coupling device. There are also ADCs, which are analog to digital converters. We'll go over what that means in a second. There's USB connector lines. There's a focus roller, magnification knob, and a stand. So it'll make sense in a second when I show the diagram of where these are and what they mean. So the CCDs are image sensors. They pretty much implement pixels and photons, and this is what provides an image. So they read the electron charges of the incoming photons. So one way we can look at it is kind of like a roll of film in a simplistic way. So the ADC, the analog to digital converter, is a digital value for every pixel. It provides a digital value for every pixel, depending on what voltage that pixel is. So each pixel is then individually read by this amplifier, which transforms these electron signals into a voltage output. So essentially, this is what's used to create a digital image with a high resolution. So something that's very resolved. So a USB digital microscope here we have is the diagram. So we have the polarizer that I haven't mentioned in that specific breakdown. I will mention that in the next slide. So we have all these different spots here. So do not use, it doesn't use transmitted light, but it uses light that's built in with the LED. And so it's reflected from the specimen back into the camera lens. I couldn't draw a diagram because it was too confusing to write that, so that's the way it works. So this is the specific model and make that I used. So as I said before, it contains the polarizer, the magnification range of 5 to 140 times. And then these extended depth of field and extended dynamic range, which I'll go over in a second, with also a high resolution, as I mentioned previously, with the pixels listed there. So here we have to the left-hand side the polarizer. I did not use this or change this at all with my specimen, but it does assist with surface detail and contrast as it eliminates reflections. I didn't really need that as much because the detail I needed was somewhere else. The EDOF capture mode is pretty much, it just automatically will stack the images that have each image will have a different focus, and then it will stack all these images together to create a very crisp image, while the EDR capture mode is used on high contrast or reflective surfaces to provide a better image. So here's just a quick overview of a chart kind of summing up what levels of magnification you're on, and the associated working distance, field of view, and depth of field that coincides with this for the digital microscope. So the parameters that were used to acquire my Song of C were taken between 5 times and 140 times, and they were examined at various working distances, as well as the polarizer was not implemented. So this is Song of C, and I don't know if anybody has any guesses as to what this might be. But take a good look, and I will give a hint. Song of C microscopically tears bacteria to pieces. And the second hint is that this specimen may inspire new surface technologies, as researchers are looking for insight into Song of C for reference to designing artificial surfaces with de-icing, self-cleaning, and anti-fogging abilities. So last guesses. And it's the cicada wing. So the beautiful sound of summer is this, and it relates to biology and innovation and nature, which hopefully we will all see very soon. And I hope you enjoyed my presentation, and have a safe rest of your time off. Thank you.